Okay, so we were discussing question number 6 and we have to start question number 7. So they are saying this question is about group 7 elements and their compounds. Chlorine is used to treat water even though it is toxic to humans. Give one reason why water is treated with chlorine. Give one reason why water is treated with chlorine. So explain why chlorine is added to water even though it is toxic. Give an equation for the reaction of chlorine with cold water.
So that the chlorine is added to water to um like make it more alkaline to get rid of any bacteria, I think.
Uh, Basically, when chlorine reacts with water, it produces HCl and HOCl. HOCl is hypochlorous acid and it acts as a bleaching agent. And it acts as a bleaching agent. So that's why we can say that reason chlorine is a disinfectant. Chlorine is a disinfectant basically. It's a disinfectant.
Also, you're recording, right? Right. Okay, okay. I can't see
And
your screen.
okay, so chlorine is a disinfectant, and also when chlorine is going to react with water, so it's gonna produce the two products. One is HCl, and another one is a HOCl. So this HOCl acts as a, we can say, as a bleaching agent. Basically, it kills bacteria due to the formation of HOCl. So I can explain it. HOCl acts as a bleaching agent used to kill bacteria. Used to kill bacteria. And they are saying uh, solid sodium iodide reacts with concentrated sulfuric acid to form iodine and sulfur in a redox reaction. Give a half equation to show the conversion of iodide ions to iodine. Okay, give a half equation to the conversion of sulfuric acid to sulfur. Give an overall equation. So when iodide ions are going to convert into iodine, so I can say it's gonna be 2I would be losing 2 electrons, and converts into sulfuric acid converts into sulfur. Sulfuric acid converts into sulfur. So then,
Oh, wait, that's just the equation for the sulfur? Or like will we add water or something like that?
yeah, then we have to balance it, by the way. So oxygen is balanced by water and hydrogen is balanced by H positive ions. I'm supposed to write 6H
Hmm.
plus. Then I'm going to write 6 electrons. Then we have to balance
Okay.
this equation. It should be multiplied by 2. Should be multiplied by 2. Like first of all, this one,
Wait, why are you multiplying that equation by 2?
because when we are going to add the two equations together, electrons should be cancelled. So it should be I can say 3 2 into 6 is 3I2 and again it's 6. So when you will be
So
adding
you're multiplying it by 3, not 2.
6I minus plus 6H plus H is so
So
4,
you're multiplying it by 3, right?
yes, H plus 4H2O. Other sulfur containing reduction product. Other sulfur containing reduction product.
What do they mean?
Any other product in which the oxidation number of sulfur would be lower as compared to the sulfuric acid. Sulfuric acid means that in which the oxidation number of sulfur, in which the oxidation number of sulfur is plus 6. So I'm supposed to take SO2 in which the oxidation number for sulfur would be, I can say plus 4. So it's also a reduction product.
Sulfur dioxide.
So it's also a reduction product.
All right.
Yeah. Okay. So see this one.
So this one excess is used so that all the um so that all the reactant reacts or something like that.
Yes. Basically, a student completes an experiment, okay, to determine the percentage by mass of sodium chloride in a mixture of sodium chloride and sodium iodide. The student uses this method. 600 milligrams of the mixture are dissolved in water to form a solution. Okay. An excess of aqueous silver nitrate is added to the solution. This forms a precipitate containing silver chloride and silver iodide. Excess dilute ammonia solution is then added to the precipitate. The silver chloride dissolves. The silver iodide is filtered off from the solution and is then washed and dried. The mass of the silver iodide obtained is 315 milligrams. Silver nitrate is added to the solution. Suggest why an excess is used. Because you have two solutions. In this, you have two solutions. So if you have two solutions, so it means that basically iodide would be reacting with silver nitrate, and also the chloride would be reacting with sodium nitrate. So when they will be reacting, so of course more silver nitrate is needed so that we can make sure all of the halide ions have been reacted. Nothing is left. If someone is left, so we will think that the precipitates are formed, but it's, by the way, it would be the remaining amount of the halide ions. So to make sure all sure all the halides have been reacted have been reacted. Calculate the amount in moles of silver iodide obtained. Yeah, this is easy. So see this one, silver iodide. Mass of silver iodide obtained.
Hmm. So we'll just do 315 divided by 234.8.
315 milligrams divided by
Which I'll have to convert by into
234.8.
grams. No, I'll have to
So,
convert 315 into grams, right?
so 10 raised to the power 3, right? 10 raised to the power minus 3. We are going from milligram to gram. We are going from milligram to gram basically.
Right. Okay. So
Yes.
uh 1.3 1.3 times 10 to the power of negative 3.
1.3 times 10 to the power negative 3. Okay. Calculate using your answer to question 7.4 the mass in grams of sodium iodide in the mixture. NaI. NaI.
Okay, wait, we need to find NaI, right?
Yeah, NaI.
But they have only given us the silver iodide. Like they haven't 600. Well, like how do I find the number of moles?
Uh, Basically, they were saying that percentage by mass of sodium chloride in a mixture of sodium and sodium iodide. So we have a mixture of sodium chloride and sodium iodide, right? So 600 milligram of the mixture are dissolved in water. They are dissolved in water. Then an excess of aqueous silver nitrate is added. Then silver nitrate is added. As a result of this, silver chloride and silver iodide would be formed. So the ratio is 1:1. Since they have given you the mass of, like they are asking the mass in grams of sodium iodide. Since the ratio is 1:1 between the moles of silver iodide and the moles of sodium iodide, I would be using the same mole ratio. So mass is equal to time moles. 1.3 exponent minus.
Okay. No, I don't get, like, we found out silver iodide's mole, right? So what's the mole ratio then?
NaI NaI was reacting silver. It was producing AgI and NaNO3. This is a balanced chemical equation. So I took the mole ratio between this one and this one. That is 1:1.
Oh, okay. Oh, then you'll just do this. Okay. So answer is 0.19 grams.
0.19.
Yep.
Okay.
What's the formula for percentage by mass?
Sodium chloride in the mixture. So sodium chloride divided by the sodium chloride and sodium iodide multiplied by 100.
Okay, so what was the mass that we found out for NaCl? It was 1 point something, right? Like I think they've given that actually. 315 for silver iodide. So even for uh, wait, what do I have to find? NaCl, right? Oh, NaCl divided by NaCl plus Na. So sodium chloride and then sodium chloride plus sodium iodide. And a mass of sodium iodide, which is 0.19. But what about sodium chloride?
Since the mole
Did
ratio is
we?
the same, since the mole ratio is the same, so the number of moles would be equal to sodium, like like the moles of silver iodide is equal to the moles of sodium chloride. Like if I make an equation, so we will see that AgO3 is reacting with NaI. No, sorry, NaCl. It's gonna produce AgCl and NaNO3. Again, the same thing. Mole ratio is the same. So then you have to find out the mass. Then you can put the mass over there.
Okay. So what is the number of moles, by the way?
Number of moles of silver iodide.
1.3, right?
It's the mole of silver iodide.
Yeah, yeah, but the molar ratio is the same, right? So I just have to multiply this number of moles by the amount of chlorine, or I mean of NaCl, which would give me
Yes.
the moles, which is 0.076.
Mm.
0.076 is the mass of chlorine, of NaCl, sorry. My final answer is 28.5, 28.6.
28.6.
Yeah.
Okay. This question is about a volatile liquid A. A student does an experiment to determine the relative molecular mass of liquid A using the apparatus shown in figure 2. The student injects a sample of A into gas syringe in an oven at the temperature of the oven liquid A vaporizes. So they are asking calculate the MR of A. Give answer to three significant figures since the R is given to you. So you are supposed to use PV is equal to nRT. PV is equal to nRT. We can use this. We will be getting the MR. We will be getting the MR.
Okay. Wait, no, sorry, what? What am I?
MR. PV is equal to nRT. MR of A. Since the data is given to you, since the data is
Yeah.
given to you, so volume is given, pressure is given, everything is given in this. So how do you calculate this one?
Can you scroll up? I want to read the question again. A little bit of. Okay. Alright, here you can scroll down. So PV is equals to nRT, right? Then what do I find with P? Like, scroll down. So we have the mass. So we need to find the number of moles. We need to find N. We already know what R is. and RT. We also have the temperature, which we have to convert into Kelvin, and then pressure is also there, which we have to convert into Pascal. Volume we have to convert into meter cube. So yeah, we can then find out then uh we have the mass and we also have the MR, I think. So we can divide them to find out the number of moles and put that into the equation. But then we have like everything. What do we need to find?
Volume is given, pressure is given, temperature is given, mass is given. So you can find the MR. Number of moles are equal to mass over MR. Since the mass is given, so you can apply the formula. You can apply the formula, so you will be getting the mass.
No, no, we already have the mass given, right? No,
You-
that's of the needle syringe. Wait, could you repeat like what am I supposed to find again?
MR.
MR. Do we have the number of moles?
Moles are equal to mass over MR. You can directly find MR. Or
Ah,
else you can
right,
find
right.
out the
Got
N
it.
first. After getting the N, you can multiply it with this one. You can divide it by mass to get an MR.
Right, got it.
So basically, PV equals to mass over MR into RT. MR would be equal to MRT over PV. So mass is what? So mass is what? Mass is okay. Mass of a needle syringe and contents before injecting. Mass of fine needle syringe and contents after injecting. You can subtract it to get the difference. What's the difference?
Uh, difference of what difference?
11.295.
Yeah,
11.295 minus 10.835.
that is 0.46.
0.46. 0.46 multiplied by 8.31 multiplied by the temperature, that is temperature 120 degrees Celsius. So 120 plus 273. 120 plus 273. It's gonna be okay. Then divided by P. P for pressure. Pressure is given, that is 100 kilopascal. So 100 is going to be converted into Pascal multiplied by 1000 multiplied by the volume. That is volume of reading on a gas syringe before and after. So is 178. Yes, 178. 178. It's in cm cube, I think. Yeah, it's in. We have to convert it into meter cube multiplied by 10 raised to the power minus 6. So 178. Then we have to find out the MR directly. What's the answer?
1 second, I'll find it out. You convert right. You converted it, yeah, to meter cube.
Hmm,
Yeah. So the final answer here is 41.1.
41.1. 41.1.
Yep.
No, 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 no. It's wrong.
1 second. 84.4.
Exactly.
Right. I just had to put brackets around 120 and 273.
The student noticed that some of the liquid injected into the gas syringe did not vaporize. Explain the effect that this has on the MR calculated by the student. So when the sample is not vaporized yet, so of course it would not be converting into the or into the cation, because in a mass spectrometer, generally the same goes with this one. If the sample is not vaporized, so I can say that uh, they are saying the student noticed that some of the liquid injected into a gas syringe did not vaporize. Explain the effect that this has on the MR of the student, calculated by the student. So first of all, we have to say, will it increase or decrease? Since we know that the formula for the MR is mass over mole, since we know that. So since we know that MR is equal to mass over mole, mass over mole.
Mhm.
So if if the liquid did not vaporized yet, so it means that in a gas syringe, we will be collecting the less amount of volume, isn't it? We will be in a
Yeah.
gas syringe. In the gas syringe, we will be collecting the less amount of volume. Less amount of volume means that um, exactly if the less amount of volume is obtained, so when we will be calculating the number of moles, so I will be getting the less number of moles. If I will be getting the less number of moles, if I will be getting the less number of moles, since the number of mole decreases, so what would be the effect on MR? MR will increase because mole and MR, they are inversely proportional to each other. If the number of mole decreases, so the MR increases. And if the number of mole increases, so the MR decreases. So we have to write it. We will say that since we know that MR is equal to mass over mole, right? So I can say that uh, liquid did not vaporize, did not vaporize. So will be getting less number of moles due to less volume of gas. So due to the less number of moles, MR will increase. Oh, again, table 3 is repeated here. Okay. Each reading on the balance used to record the mass of the fine needle syringe and contents had an uncertainty of 0.001. Calculate the percentage uncertainty in the mass of liquid A injected in this experiment. Again, in a gas syringe, we are taking the reading twice. Initial reading and a final reading. Initial reading and a final reading. So we have to multiply this by 2. If you remember, we used to do
Right.
this for the thermometer and for the burette. Because whenever we use a burette, so we take initial reading and final reading. So of course the error would be with the initial and the final reading as well. So I have to multiply the I have to multiply the uncertainty by 2. And if we are using the thermometer, again initial reading and a final reading, so we have to multiply this uncertainty by 2. Again, in this question, we are using gas syringe, so we have to take initial and the final reading. So what I would do, 2 multiplied by the 0.001, they have given you the value, divided by the total. Divided by the total, we got the MR, we got the mass that was, I think so, 0.46. Yeah, 0.46 multiplied by 100. What's the answer?
Okay. But I don't get why you multiply it by 2.
Because some instruments we use once, like pipette. We don't take initial
Hmm.
and final reading. So for those, we are not supposed to multiply this by 2. But for
Oh, by the
those,
way, the answer that I'm getting is in decimal 0.43%.
okay,
That should be
yes, it's of 1 mark.
right.
Which atom has the smallest number of neutrons? Neutrons.
Um, has the smallest number of neutrons.
It's
Uh,
going to be
at 1 second.
it's going
Need
to
to
be
check.
3 minus 1, 2, 2,
Two, two,
3,
three. So last one.
1.
These answer.
Which species contains bonds that have different polarities?
1 second. Different polarities. I'll check. NH4 plus. Uh, NH4 plus is quite similar, I think.
Yeah, exactly. It's non-polar, quite
C
near to.
CCl4 is
Again,
also
it's symmetrical
CCl4 could
structure.
be, but it's similar as well. It's
Yeah,
similar. CH3Cl is also similar. I think it would be H3. No, H3O is also similar. It could be CHCl. I think.
it's similar. It's similar, but but the presence of chlorine is destroying the similarity of CH3Cl. If there would be 4 chlorines, so yes, I would say that it's similar. If there would be 4 hydrogens, so then straight away I would say that that's going to be similar. But if we have 3 hydrogens and 1 chlorine, so basically this hydrogen and this hydrogen are going to the cancelling the polarities of each other, but this is not. So due to the presence of chlorine, the molecule is going to be polar. So yes, the answer is C.
Okay.
Which compound has hydrogen bonding? Of course, it's straight away. It's
B.
ammonia.
Yeah, B.
Which reaction has an enthalpy change equal to the standard enthalpy change of formation of lithium fluoride? So you have to see the definition of a standard enthalpy change of formation. What's that?
D. Is it D?
B for ball or D for doctor?
D. D. Doctor.
Yep. Yes. Good.
I didn't even go
Is it
through the
C?
other options because I think that D would be the correct answer because lithium is usually solid, like it's a metal, and fluorine is a gas. So, and fluorine is F2, so it's either A or it's either D. But I don't know why. Oh, yeah, in A, lithium is a gas. So,
Yeah,
I
exactly. So,
think.
so standard state for the lithium is solid at room temperature.
Mm-hmm. Okay. All right. NO2 ions can be reduced in acidic solution to NO. How many electrons? Um, 1 electron.
Mm,
Because it's only minus, right? Like, so it just needs 1 electron, no? Oh wait, there's oxygen as well. There like two oxygens are gone. Like one oxygen is gone. I'm not sure.
Yes, A
Is
is
it
correct.
A?
Yeah.
But then how is like another oxygen gone? Is it like they're canceling out when we do the
They are
cross
talking,
thing?
yeah, exactly. They are talking about the charge. So we have to see the charge only. So in the end, they will be canceling each other.
No, no, because the charge of nitrogen is 3 minus, right?
NO2 minus getting
Hmm.
reduced to NO, H2O, 4H positive ions, right? How many?
Oh, you're balancing it like this. Okay,
Yeah, how
okay.
many electrons are gained when each NO2 minus ion is reduced? So one electron, since the charge is one.
Can I, like, what I thought was that NO2 and then the charge on the entire ion is like just negative. So to turn it to like just positive, we'll just have to get one electron.
Yeah,
That's what
we
I thought.
yeah, exactly. We can see as well. You're thinking like that.
Yeah.
Uh like this one, right?
Yeah, yeah.
Yeah, okay.
But what confused me was that there were two oxygens. Like, that's what confused me.
So basically oxygen is balanced by water.
Okay.
Only two unpaired electrons.
Uh, wait.
One, two, three. It has to be, if I can see, to be four. One, two, three,
There's just two
four.
unpaired electrons, so it's B.
Exactly. Correct order of increasing radius of the ions.
Um, so as you go from the left to the right, protons increases, attraction increases, radius decreases. So on the right hand side, there is going to be a smaller radius compared to the left hand side. So increasing radius of the ions. And when you go down the group, the radius also increases. So chlorine. So A is wrong. And then B is correct, I think.
Uh,
C is
first of all, the thing is that uh,
and
cations are smaller or anions.
uh what?
The size of cation is smaller or anion.
Uh I think cations are smaller.
Exactly, cations are smaller. So we are going from smaller to the larger. So the answer may be B. The answer may be C. Then we have to think again. Uh, Beryllium is in group 2. Lithium is in group 1. Across the period, size
So it
decreases.
should be C.
See, exactly, it's C, it's not B.
I
Okay.
thought I said it was B, right? Right. Okay, so it was C
Which
because
compound contains a coordinate bond?
um think it is NH3.
Uh,
No,
it
it can. It's
contains.
not. It doesn't contain. No, no, it
Yeah,
doesn't contain.
exactly.
It can get like one more hydrogen, right?
Exactly.
But it doesn't. I think it would be. Can you draw CHCl3? I think it could be that one.
CH3 has no any lone pair of electron. It has no any dative bond because carbon has a 4 valency. It's going to make 4 covalent bond. So it's already
Right.
full. 1 hydrogen and 3 chlorine. So the total 4, of
So it
course.
has to be D.
If you remember in a chemical bonding, we did, yeah, exactly. When ammonia reacts with H plus to form ammonium, or even I can say when ammonia reacts with Cl to form ammonium
NH4.
chloride. Yes, exactly. Which
Right.
property
Okay.
increases down the group 7? So I can say that increases ionization energy. No, 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 no. Uh, boiling point, yeah, boiling point increases. You know why? Because down the group, IMF increases. Down the group, IMF increases. Why? Because number of electron increase. That's why.
Okay.
Which of these elements has the highest melting point? So yes, it's very easy. Giant.
Um,
It's a giant
Giant
structure.
macromolecular structure.
Which statement is not always correct for a reaction at equilibrium. Reactants product. The concentration of the reactant and products are equal. Not always correct. Okay. Okay. So A is correct. Yes.
Yeah, is correct,
Because you
right?
know, for equilibrium, the rate of forward
Also
reaction is
B,
equal to the rate of backward reaction. It doesn't like it's nothing about
no,
the
there are also
amount of.
which is not correct, which is not always correct.
Yeah, exactly. This is not always correct that the concentrations are equal. No, it's not always 100% true. Sometimes they are equal, sometimes they are not.
Okay.
Yeah, let me
For
tell
like
you this one.
equilibrium,
Like let's say if we have 40 grams of reactant and 60 gram of product. Concentrations are not same by the way. They are different. So what's going on in the equilibrium? Some particles are moving from right to left. At the same time, the particles are moving from left to right. The change is very smooth. The change is very smooth. So I can say the equilibrium is established because the change in particles are very smooth. It's not like that the amount of reactant and amount of product. It doesn't depend on the amount of reactant and the product. So we always look at how much particles are changing from left to right and right to left, and that's it. If the change is smooth, so we can have an equilibrium. It doesn't depend on the amount of reactant and the amount of product. So that's why A is correct.
all right, okay. Because I thought that in equilibrium that both the concentrations of the reactants and products would be the same, and the
No,
forward
no, no, no,
reaction
no,
is
no,
equal
no,
to
no,
the
no.
backward reaction.
It's a general equilibrium. When we discuss dynamic equilibrium, so there is nothing like amount of reactant and product.
Right. Okay.
Okay. So what is the enthalpy change for this reaction?
Uh,
It is 272 and its value is
how would you do this, sir?
22. Since we know that FeO is given and this is going to be reacts with oxygen to form FeO. And by the way, this is standard enthalpy change of formation. So we have to form this one.
Hmm.
This is formed by the reactants, by the elements. So since the energy is given minus 272, I have to multiply this by 2 because the coefficient is 2. And then again, a standard enthalpy change of Fe2O3 is given. So again, the reactant would be the same, Fe plus O2. Since again the value is given that is minus 822. So
Hmm.
then I'm going to do indirect route.
Reaction minus product, right?
So yes, minus plus 272 times. and minus 822. I'm going to change the sign of this value because no, I'm going to change the sign of this value. I'm going downward, the arrow is going upward. It's just opposite to me, so that's why I'm supposed to change the sign. I will not change the sign of the product side because the direction is same.
Same assignment.
Yeah.
Okay. So how did you deduce like and find out it's going to be Fe plus O2? Why not something else?
Because according to the definition, when 1 mole of a compound is formed from its elements. So I saw that in this compound there is Fe and O, so that's why I have decided that the reactant might be Fe and O2. Because the
Got it.
standard state of oxygen is O2, yes.
All right. I'll just find the answer. Negative 548. So A.
A is correct. Okay. A or B?
21's answer I
A,
think would be A.
A or B? This one.
1 second. Oh, I think I did. No, wait, I made a mistake. I did 272 plus 2. 272 times 2.
272 times 2 minus 822.
278. Sorry, B. I don't know why I did
Which
plus 2.
compound
Miscalculated.
contains chlorine in an oxidation number of
A,
plus 1
A.
minus 2 plus 2?
It should
So,
be A, right?
yeah, A is correct.
Yep.
2Cl plus minus 2 is equal to 0 is equal to plus 2 and Cl is equal to plus 1. Yes, okay. Which equation shows a redox reaction that doesn't occur?
Okay, for this one, redox reaction that doesn't occur. Okay.
It's a displacement reaction, yeah. So more reactive halogen is going to displace the less reactive halogen. So it's going to displace the less. Yes, this is correct. It's more reactive, it can displace the less. Yes, this is correct. It's less reactive. Yes, correct. This is wrong because iodine is less reactive, it can't displace the bromine. Since this is going to be less reactive and the bromine is more reactive, so this reaction doesn't happen.
All right.
Which molecule has a permanent dipole? The molecule which is not going to cancel the dipoles, that's going to be having permanent dipole. Simple.
Permanent dipole. What does permanent dipole mean again?
Like let's say CF4 is going to be this one. The dipoles are
Yeah.
canceling each other. And if we can make
What's
PCl5,
a
so it's
dipole?
gonna
What's
be,
a dipole? What's a dipole?
there would be a charge. There would be a charge that might not cancel. Carbon dioxide is this one. Cl2O is going to be like that. And we have a lone pair of electrons. So
What is
due
this
to the
AA
presence
thing?
of, sorry,
Oh, never mind. Right. Okay. Okay. All right.
so they are going to cancel each other. This fluorine is canceling this fluorine is canceling this one. It's so non-polar. Again, again, this is the similar structure. They are going to cancel each other. Again, it's going to cancel each other. So the answer is D.
Can you tell me how they're canceling each other in B, in part B?
Basically, it's a similar structure. If you will see the 3D structure for the trigonal bipyramidal, okay, this
Mm.
is trigonal bipyramidal. So you will see that they are going to cancel each other. So that's why it's going to be non-polar.
No,
There
like
is no lone
how?
pair of electron. Okay, there is no lone pair of electron. Basically, you are thinking that it's going to cancel each other. They are going to cancel each other. Then what about this one? No. We
Exactly.
have to see the overall similarity of the molecule. The geometry of this molecule is designed itself, of course, uh, in such a way that this molecule is a completely having a similarity. So if we are going to compare this one and this one, so the best answer is this, not
But
this one, because it's
co-
going to have a lone pair. So it's more polar as compared to this one. And also we can say that it's going to have the highest electronegative element, that is oxygen. Due to the presence of highly electronegative element, so I can say that this is going to be the more polar one. It's having a permanent dipole.
Also,
In
sir,
order
one more thing. So whenever there's like a lone pair, we can just say that that one's like a permanent
have a
dipole.
permanent dipole until or unless there would be any similarity in the molecule, the structure is going to cancel each other. So it
Yeah.
depends. So we have to see that structure.
So in this case, like the chlorine and chlorine cancels out each other, right? In the
Yeah.
D,
Yep.
but it has like a lone pair, which makes it a permanent dipole.
Exactly.
Okay. All right.